Hey guys, if I want to say that two triangles are similar to each other, there are some proofs or rules that I would use to say that. The first is the side-side-side rule, side-angle-side rule, or angle-angle rule. So if all three sides of the first triangle are similar to that of the second, if two sides are similar with the same angle in between, or if two angles, which really means three angles, are the same. By similar, I want you to remember, we're not talking about congruence. Okay, similar doesn't mean they're the same as it did with congruence. Similar means they're in the same proportion. And proportional means that things grow or shrink by the same amount, like just like a person, right? If you're proportional means you're properly aligned. If this triangle is twice as big as this triangle, then all the sides have to be twice as big. If this triangle is 5 times bigger than this triangle, then all the sides have to be 5 times bigger. They have to be in the same proportion. If it's half as big, they all have to be half as big. The angles have to be the same. And if you have two known angles, obviously that implies a third known angle, as we saw previously. So we're going to look at these three rules and see which one will allow us to say what we want to say. The angle-angle rule, if you take a look over here on this triangle, I don't have any known angles, or at least not any identified angles, and so I can't use angle-angle to try to show that these are similar. And side-angle-side also no good to me because I only have over here one identified angle, but I don't have any identified angles in this triangle, so I can't use a proof that requires an identified angle. So I have to try using the side-side-side rule to see if these two triangles are similar to each other. So triangle ABC has 3 sides, and triangle GHI has 3 sides, and I have to see if they have the same scale factor or if they're in the same proportion to each other. And the way we do that is by dividing. So really simple. I'm going to set up a side from this triangle with a corresponding side from this triangle. I'm going to have a big side, I'm going to have a middle, and I'm going to have the small sides. And I'm going to compare them. I'm going to divide them and see if they're in the same proportion to each other. So I'm going to look here for the biggest number, and the biggest number here is a 30. And the biggest number over here is a 97.5. So I'm going to say, okay, for the big triangle, if I go 30 divided by 97.5, that's going to give me a number. We'll come back to that in a second. Now the middle, I've got a 30 matched with the 97.5. Let's find the middle number. The middle number here is a 24, and the middle number here is a 78. So 24 divided by 78. And then the small sides, 18 with the 58.5. And that's going to equal something, some number. Now, if all three of these numbers are the same, if they have the same scale factor, then we could say the triangles are similar. Thing to notice here is it doesn't matter which side you put on the top and which on the bottom. You'll notice here I have the smaller triangle on top of the larger triangle. I could go the other way. I could go 97.5 divided by 30, but if I do that, then I'd have to go 78 divided by 24 and 58.5 divided by 18. They have to be in the same order, top and bottom. Which one's on the top and which one's on the bottom doesn't matter, but once you make a decision for the first one, you have to respect that pattern for the other 3 fractions. So once I made the decision to put this triangle on the top and this triangle on the bottom, and I have to stick with that. So now, all I have to do is check to see if these 3 numbers come to the same proportion. So here I've got 30, and I'm going to divide that by 97.5, and when I do that, I get this crazy number over here. 0.30769. 0.30769. We'll see what happens. 24 divided by 78. 0.30769. It's looking good. Let's try this last one. 18 divided by 58.5. Look at that. 0.30769. In other words, this triangle is 0.30769 times smaller, I guess, than this triangle over here. Each one is about 31% of that one over there. So I can say that they're similar, and the justification is that all the sides are proportional and have the same scale factor. Easy peasy. Let's take a look at another one.